own devices and do some other cool stuff. So, and here's Ryan Clarke.
Hi, sorry for the delay in setup. Some of the things that were going to help me with my setup are actually somewhere with the TSA. I'm not sure where because I went through my luggage before I got here, and when I opened my bags here, some of my stuff was missing. So if I go to get a part and I don't have it, bear with me. We'll do the best we can. My name is Ryan Clarke. I go by Lost. Some of you may know me from the DEF CON competition. Some of you may not. And let's get started. I've got quite a few things to cover today. I do want to preface this by saying I have been championing the cause of bringing more people to the dark side of hardware. I know there are a lot of you out there who are gifted programmers, but I get the response from a lot of people, I don't touch hardware. That's why I'm here. That's why I'm at DEF CON, is I'm trying to bring you guys to have a more well-rounded tool palette, if you will. So, and that's why this talk is actually entitled Extend Your Code into the Real World. What this talk is not today, in case you have any false expectations, this is not a step-by-step how-to for anything. That's impossible to do in 50 minutes. This is bits and pieces of information to help you get started on your way, kind of like most of you had when you went to college. You know, I didn't go to college. It cost about, several $1,000s. I love hardware contests. Does anybody remember the boxes by chance? A few of you? These are the mystery boxes from the DEF CON contest last year. The only reason I bring that up is that this contest actually came out of previous hardware contests having a very lackluster showing, which is kind of disgraceful in my opinion for the hacker community. We have a lot more cool stuff hardware-wise coming out of the community, and I think hardware is on the rise again. I think if you look at the way things are going, trends are putting hardware back in the hands of the people, and we're going to talk about that a little bit. Basically, I made a commitment to myself that at this talk, I'm going to publicly state this is the last time I'm going to explain the mystery boxes to anyone, because I've been asked so many times after DEF CON. Like everywhere, any conference that I go to, people come up and they want to know about the mystery box. A lot of people didn't hear about the contest until after it was over, and then they heard it was really great. Please tell me about the mystery box. Basically, it was an embedded processor on the front. They had diffused wires in a particular order. It gave them a number. They got inside. There was a pirate map, which was a schematic that was encoded as a pirate map. They had to build another circuit inside, got another piece of information with an RFID tag. Long story short, they got 3 numbers. They had to sum them, realized that the number in binary was 1 digit shy of being a palindrome, invert all the bits, convert it back to decimal, and enter that as the password, and that was the full contest. I'm done. Don't ask me again in public. So, and along those lines, I'm running a mini contest right now. Hopefully, if it's up, do you see it, Thorn? Yeah. Anyone with a laptop or Wi-Fi device, I'm broadcasting all doors open. The SSID is lost at Shmoo1862. It's running off of this piece of crap D-Link that I stole from a friend of mine. Please don't pwn the D-Link. It's not the contest. What's that? Did you? Is it still accessible for other? I left it open for everybody. I didn't do anything to protect it because that's not the point of the contest. What I want to do is I want to show you what it is that you're dealing with here. And I have hints throughout my presentation, and the hints are actually labeled as hints, so it's pretty blatant because we only have 50 minutes. I got a lot of stuff to talk about, so I anticipate somebody getting there. Is somebody connected? Can you toggle the laser on and off for me, Thorn? What Thorn is doing is he's accessing a web interface that's actually not on one of these computers. It's on this embedded board here, which I'm going to show you in a second. But I only have one feed, so I have to switch between laptops so he can put the webcam on so you can see it. Can you toggle that on and off? Anybody right now that accesses the web page should be able to turn this laser on and off. Now, the problem is if a whole bunch of you are doing it, it's going to of packets. It should be able to handle the traffic, but if anyone wants to log in, the web server is actually on 192.168.0.21, and it's running off this device. And let's switch to that right now so you can see it. And I promise I won't go back and forth that many times. and that's not going to come up. This is actually a laptop I borrowed also because it's just a dummy for the webcam. Okay, forget it. It's going to take too much time to switch back and forth anyway. So I'm going to actually just show you the device. The device is right here. The web server is this module here. And I helped and develop the firmware for it. It's running a Coldfire chipset from Freescale, if you're familiar with it. It's actually a very, very capable little device for what it is. And beneath it, you'll see the parallax board with the basic stamp on it, which we'll talk about in a second. So the brain of this is a BS2 PX24. Now, I know that there are those of you out there who are going to kind of poo-poo the using of a basic chip. The reason I did that in this talk, and I will tell you that my drug of choice is the SX from Uwicom. I prefer to chip in assembly. However, for this talk, since this is a hardware-based talk, I thought that the most accessible chip to use would be a basic stamp, so that language is not the issue, okay? And I think that that's a good way to start. The web server is an SB70 module from NetBurner. I would request that anybody who decides to build an embedded device, if they use this module, send me an email, because I can't publicly state there's a flaw with the device. There's actually a back door on it. So it's not secure, but make it secure. If you contact me, I'll tell you how. And this device is actually connected to this breakout box, which contains 4 SSRs. And for those of you who are not hardware people, SSRs are solid state relays. What those are switches that I can switch 120 volt AC or 110 volt AC without any moving parts. And the way they do that is they have a photoresistor and an LED encapsulated in plastic. And as you turn the LED on and off, the photoresistor detects whether the light is on or off. That's how you make a switch without any parts. I'm going to show you a little bit of detail on the breakout box here, just because I thought it was interesting. You've all seen the video that went around of the guy that did the Christmas trees and lights in his yard synchronized to music. This type of device is what you would use to do something like that. I actually animated my own Christmas tree probably 3 years prior to him doing his yard. But this box is made entirely of parts that you can pick up at Home Depot for $10. And what this box gives me the ability to do is through microcontroller control, or if you're a PC programmer, directly from ports on your machine, I can switch these parts on and off, the plugs. And the intent of this contest, for those of you who have gone to the page, is there is a page you're supposed to try and get to where you're going to turn relays on and off on this box, which is what our blue light special light there is. So whoever the first person is to get to that page before the end of my talk and turn that blue light on, and we'll all see it, I got a prize or something. So if anyone can get to it, if not, I'll show you how it works at the end. We lost the screen. I am aware that you're all armed with Shmoo balls, and my intent was to build an anti-Shmoo ball defense system. That was not finished in time for this conference. My services will be for hire for speakers next year, by the way, if you want an anti-Shmoo device that will fire back. I'm working on hopefully tracking into the audience, and maybe you can at least fire in the vicinity of anyone who fires a Shmoo ball at you. However, I will warn you that I am armed with ninja stars. I'm not kidding. And so if anyone has a Shmoo ball and decides to throw it at me, I'm going to counterattack, just so you know. So let's talk about hardware. The word itself has the word hard in it, and sexual references aside, I think it's a mistake, because I really honestly believe that dealing with hardware is actually easier than dealing with software. And if you want proof of that, consider how many devices you have that are a set piece of hardware that you can load different firmwares on and get completely different functions out of. You can constantly change the firmware, yet the hardware remains the same. The complexity of the hardware never changes. What changes is how you implement the things you do with that hardware. I think it's also very interesting at this conference that the very first presentation dealt with FPGAs. Go hardware. Look, it's coming full circle. We saw, you know, how many were at the very first presentation? How many were impressed with how fast that FPGA could do things that the computer was, you know, orders of magnitude slower on? How many of you think then that maybe there's something to this hardware stuff? There you go. So the day of the hardware hacker is back. How many of you have been to one of Joe Grand's presentations on hardware hacking by chance? All heard. Joe Grand has this way he describes the ability of us, and by us I mean the the casual hardware hacker, if you will, or the garage person, or however you want to describe us, i.e. non-well-funded private individuals. He calls it the technology divide. And what the technology divide is I have major corporations with the ability to do R&D and development here, and I have my ability as Joe Schmo going to Radio Shack buying parts here. Now back in the early days of through-hole components, everybody's familiar with the term through-hole? I don't need to go into that. Okay. Through-hole components, major manufacturers, we're right here. We're really close. Then you went along, and all of a sudden, surface mount technology hit, SMTs. Bang. It became very, very expensive to produce electronic components with surface mount stuff. It took a lot of things out of the hands of the amateurs, or the hackers, or us. Same thing with the FPGAs. Everyone got excited when they saw that first presentation until they heard the price tag. Ooh, FPGAs are expensive. Part of what they're doing and part of the benefit of that product is they're taking a chip that uses something called BGA or ball gate array. Basically, they're little solder blobs on the bottom of that chip. It's a form of surface mount technology, if you will, that's melted to the board. That's really hard to do in your garage with a hot plate. You know, you can't go to Radio Shack and buy the parts to do that. Now, you can hand solder some surface mount stuff, but it's not easy. And so the technology divide went like this for a while. And manufacturers and companies are producing all this stuff. Well, now we have cheap manufacture available to us. How many of you have heard of Express PCB or PCB Express, which are two different companies, by the way? Yeah, there's a number of them. There's a new one out of China. Basically, what these companies are is they're offering free software where you can design a circuit board, send them the file electronically. They will do an analysis for it, rule check for you. So if you're not an engineer, they'll tell you, hey, you screwed up right here, fix it. They'll produce the board, and in 3 days, you can have a fabricated circuit board in your hand, literally delivered to your door. Total cost for 3 boards from a place like PCB Express, $50. So if you want to produce your own Moonanites to scare Boston, it'll cost you about $10, $15 a board. Now, that is a phenomenal thing if you think about it. Before, companies would spend tons and tons of money producing these circuit boards, and the cost was prohibitive for me. Now I can go download free software, design a board, have it delivered to my house, stuff the board, which is adding the components, we call that stuffing the board, for cheap, really cheap. In fact, back to Joe, who is a good friend of mine, he's a great guy. Joe designs products in his lab, which is, I believe, at his house, and sells them to companies like Parallax. You all have that ability. That wasn't ever a possibility before. And so the day of you taking a bite out of those big companies is coming back. The day of making the FPGAs to crack WEP and other things on the fly really, really fast, they're coming. Well, they're here. We saw them already. But they're getting cheaper and better. So the time to get involved is here. Excuses that I hear, because I talk to a lot of people. Everybody knows if you find me at a conference, I'm going to talk to you about hardware, because that's what I love. I love to mess around with hardware. I don't want to do it. It's too expensive. It's dangerous. Ooh, electricity, I'm going to die. You know, it's too complicated, and you call yourself a hacker. I don't have the time. That's probably the only one that I will even tolerate from people anymore. And no immediate gratification, unlike software, because we all write perfect code the first time through, I'm sure. Yeah. I don't want to break it. It's getting cheap, so who cares? People are like, well, if I write a bad piece of software, it doesn't cost me anything. I just change the pile. Well, I take a less than 2-cent resistor, clip it off the board, and solder a new one on. It's too expensive. I don't buy that anymore. I'm going to show you some resources that you all have available to you. It's too complicated. No, and I will prove that to you today. Hardware development and hacking are on the rise. If you don't believe me, look at the number of publications that have come out in the recent past. Nuts and Bolts has been around a while. You have Circuit Cellar, Servo is new on the scene, who are here at this conference that have a lot of technical electronic hardware side to them. EPE, which, anyone familiar with EPE? It's a British magazine. It's actually better than the magazines we have here in the States, but you can now get them electronically online. And because this is a hacker conference, I hope nobody gets mad at me for saying this, most of these magazines, Social Engineer, you are either a student at a university or you're a developer, and you will get electronic copies of all magazines for free, with the exception of Make. They have facilities for doing that. So it's not even going to cost you anything to get the publications. And they're cropping up all the time. Robot is a new magazine on the scene. Everybody loves robots. How many heard about Microsoft's new robotics tools that have just come out? Nobody, really. Microsoft has just dumped a ton of money into robotics development. God help us. Inexpensive manufacturing. We discussed the cheap PCB manufacturing. Online parts. By the way, is still logged in here? Has anyone gotten to my page yet? I haven't seen any blue lights. No. You have facilities available to you now. Online, DigiKey, Jameco, Mauser, SparkFun, which are a great bunch of guys. Go to their website sometime. They're hilarious. Electronics Goldmine. Back in the old days, when you needed parts, you went to Radio Shack. Everybody knew that. Nowadays, you need a cell phone, you go to Radio Shack. They don't even have the component drawers anymore, which saddens me, but at the same time, now I have and now I have DigiKey. And now I can buy stuff in bulk pricing for almost the same quantity pricing that the big guys get. I get my stuff much cheaper. Case in point, your through-hole resistors, if you go to Radio Shack, you'll buy 5 of them for between $1, $2, depending on what it is. If I go to DigiKey, I'm getting, in some cases, 1,000 of those same resistors for 99 cents. That's literally how much markup Radio Shack used to have. Now that we have these online distributors available to us, ridiculous how cheap these parts are. And if you knew what the markup was on electronics based, the stuff that's being fabricated in China and sent over here, it would make you wouldn't even believe it. You think software has a markup on it. Hardware has an incredible markup on the price. Go to DigiKey, go to Jameco, go to Mauser, request their catalogs. They're free. If nothing else, in about a 6-month period, you'll have a nice stool because DigiKey's catalog is about that thick. How many DigiKey's catalog? Isn't it literally? It's about this thick, and they send it to you like every other month. I'm like, oh my gosh, they must be making more money than God if they're able to send that catalog out that many times a year, and it's that thick. It's like a phone book. Social engineering again. This is a hacker conference. I don't think a lot of people realize how easy it is. You got a comment? Is anyone else toggling it at the same time? Yeah, it's because I got multiple people going on it. So, has it been going on and off? I haven't been paying attention. Okay. Has anyone even gotten remotely close to the other page yet? By the way, if you get in through FTP, please do not destroy the files that are on there. If you do, though, if you get in through FTP, you have the keys of the kingdom anyway. So FTP is open on that, by the way. Social engineering. You can get just about any part in small quantities for free, including shipping. I'm serious. Many web pages, many companies, it's an automated process. No human being will even look at it. You go to their web page and you say, I want to mess with this IC. Please send me 5. Put it in my sample cart. It'll show up in about 5 days, probably with a t-shirt. Free. I'm not kidding. For the companies that are a little more stubborn about it, with a little bit of social engineering and social grace, you can still get your parts for free. If you don't believe me, I have an entire room full of stuff that I didn't pay a dime for. I used to. Those of you who like the super bright LEDs, Luxon, if you talk to them right, you can get those new high wattage LEDs, like the ones that are in the Surefire flashlights, things like that. I'm just throwing that out there. Finding the right parts. An invaluable reference for you is findchips.com. If you're salvaging chips and parts out of other pieces of hardware, findchips.com is your friend. What this website is generally used for is I'm looking for a part because I'm building something. What you do is you reverse engineer the use of this website and you say I'm searching for this part, because what it'll do is it'll search an entire list of vendors. And even though you're not looking to purchase, when you have the link to the vendor site, you also automatically have a link to the data sheet. It saves you an awful lot of time. It's much faster than going to most vendors' websites directly. Yes?
Back in through-hole days, you could breadboard something out if you had, you buy a chip, play around with it a little bit. I understand you talk about, you can get express PCB to fabricate your chip for you, but how do you play around with that? If you're looking for a pretty custom or a pretty small specialized chip, how do you prototype that for your circuit board?
That's a constant debate amongst people. People have different options available to them. There's a bunch of people producing boards now, like Smart Board and other type boards that you drop your surface mount parts onto. The Smart board actually, the silk screen is raised. The chip sits down in it because all chips have standard footprint sizes except for like really odd ducts. And the solder is actually contained on the board. Their ad actually shows a 10-year-old kid soldering a 40-pin quad flat pack chip. And those of you who know what that is, most people will not touch that by hand. And they show a 10-year-old kid doing it with the Smart boards. There are all kinds of adapter boards available to you now. And there's even adapters now where you don't have to solder to the board. It's like a socket that gives you a breakout for going into a breadboard for experimentation, stuff like that. In addition to that, a lot of the newer companies are putting out simulators where you can do software simulations of all of your products anyway. But that's a very good question, because a lot of people think, I can't deal with surface mount. You can hand solder a lot of surface mount parts. You can. Look up wave soldering on Google. There are tons of tutorials online on how to do this type. The guys at SparkFun have a tutorial where they through a Target and they bought 5 different household appliances to try and use as surface mount reflow ovens. They used a $15 hot plate and got better results than like a $10,000 reflow oven. It was insane, but it's phenomenal. Learn to read your data sheets just like you read a web page. These days, we have so much information thrown at us. We need to learn how to sift through this information and process it more quickly. You'll start to learn over time which things are of interest to you on a data sheet as hardware and experimenters and which things are not. It's just an acquired skill, just like now you all do it unconsciously when you surf the web. You're constantly filtering out banner ads. You're constantly filtering through data. Nobody's got my light yet, huh? Is the security that good? Come on, there's a room full of hackers. So here's my Jawa challenge. Comment to your friends, family, coworkers, weird, strange people on the street. Give me any piece of electronic equipment that you deem no longer usable, we're going to throw away, recycle, give to DI, etc., etc. I claim that within a space of 1 year, you will have a room in your house that will resemble the inside of a Jawa sandcrawler. I promise. I have one. My wife puts up with it. I don't know why, but she does. And those broken pieces of electronics are great places to reclaim parts also. You can get a lot of motors, steppers. How many of you have old broken PC parts? CD-ROM drives, disk drives you no longer use. I mean, I like taking the motors out of drives just because I got so infuriated when they kept breaking back in the day and would do the click thing. So use your old stuff and reclaim parts. It's a great source for this kind of thing. And if you're environmentally conscious, you know, you're saving some production. So let's talk about hardware. Hardware can be very easy. How can I prove that to you? I'm going to describe in general terms all of the parts you would need to build your very own remote control car from scratch in a 50-minute presentation. By the way, how many of you have no hardware background at all whatsoever? How many of you have a lot of experience? Okay, only a few of you. I'm surprised that you guys came to this talk because it's going to be a basic talk, so I hope I don't bore you. Topics for discussion specifically, I'm going to talk about microcontrollers. Please do not call these U controllers. We are an educated community. It is common practice on people in systems where they do have the ability to do the extended characters or to do a mu, to put a lowercase u, and you will see the term U controller. If you say U controller around me, I will probably hit you or something because I get sick of hearing people go, oh, it's a U controller. No, it's micro. We're educated people. Come on. Then we're going to talk about motion, DC motors, and standard servos. And there was a hint up there if you were paying attention. So here's my soapbox, really quickly. How many of you have more than, say, 10 computers in your home? By computer, I mean like a PC. Okay, how many of you would agree that the average home across the United States has between 1 and 0 computers in it? The average home, not us. How many of you say 2? And by computer, I mean like desktop PC you sit down and log into the internet with. How many of you say 3? How many of you say less than 5 in the average home? Should be all of you, in the average home, okay? How many embedded do you think are in the embedded home across the United States? It will be anywhere between 500 and 600 and 8,000 to 10,000, depending on how tech savvy you are. Case in point, how many of you have a computer with you right now, like a laptop? How many of you have a key fob to open your car in your wallet right now? How many of you have a digital wristwatch on? How many of you have a cell phone? Between those things, we've covered just about everybody. the point being, there are orders of magnitude more embedded systems in our lives than there are what you would consider a PC for your PC programming people or your Mac people. I'm not getting into that religious war. Okay? How many of you have been amazed that all of the major innovations that we've seen in several areas like gaming systems, the Wii, what made the Wii phenomenal? It's that stupid controller, right? It's not the elite graphics. Okay? That's an embedded systems. They use a MEMS in that, which is a microelectromechanical switch. It's like an accelerometer. Okay? Point being that even in things like our consoles for our video games, it's the embedded system stuff that's making our life cool. The cell phone, I mean, everyone's all excited about Apple's new, iPhone that's going to cost like $600 or something crazy like that. But again, it's the embedded system stuff. Your BlackBerry, your little Bluetooth ear set. The vulnerability points and places for attack for hardware hackers are orders of magnitude larger, in my opinion, in life than I have to sit down and log into the internet. Now, case in point, I have an embedded web server right here in this chip. It's not even a computer. It's just a stupid little board running off of a 9-volt power supply. Everybody knows that the reason they're pushing for IPv6 is so they can web enable everything in your life, right? Go to your appliance store, look at your refrigerators. They have Ethernet in them now, right? So they can call, send you an email when the fridge goes down. They're talking about web enabling everything. We've heard this for a long time. It's going to start happening. And a lot of people have asked me to see these too, so I brought what is the current crop of embedded web servers. And I'm going to go from largest to smallest. Any of you read Circuit Seller magazine? Any of you familiar with Fred Edey and his group? This is Fred Edey's EDTP. It's an easy Ethernet module. It's got an RJ11 jack on it and a serial port for programming, and then it's got the Cat5 interface, the RJ45. That's an entire web server right there. Everything. Don't need a computer. Okay? So keep in mind the size there. Then he has, and I love the name of this one. This is also Fred Edey's. It's called the Packet Whacker. It's also basically just Ethernet on a chip. So if you wanted to take those FPGAs that we talked about in our first talk, connect them to the web, and all of a sudden you have your tool online for doing this really fast. I mean, dial home device, pocket runs off a 9-volt. You hide it up in the ceiling. Keep in mind of the size. We're getting smaller. This is a new one. This is from a company called Tibo. And it's actually a Japanese company, but it's produced in Taiwan. Yes?
Did you actually test the blue light to make sure you actually turn the switch on?
Yeah, they're on. Did you toggle it? It should be on.
Like the rotary switch there?
Yeah, and it's not the only thing either, because I can, unless somebody broke the module.
There we go.
Yeah, hold on. Try that. Great, you guys, you broke it, which is what I was hoping for, actually.
Was it supposed to use Metasploit?
Can you toggle it?
Try.
Are we plugged in? We're plugged in. Well, I'm going to switch over to my machine in a second, and I'll make sure it's up and running. Okay, we got the Tibo. We're going smaller now. This is the one from NetBurner. This is the SB70 module that I helped develop the firmware for. This is also what's running up here. Was running, yeah. This is the site player module, also a complete web server. We're getting smaller now. And my favorite. Does that look like an RJ45 jack? That's a Lantronix export. That is a complete web server, including all of the memory storage, all of the magnetics, everything. Some friends and I have actually taken these and taken traditional network cards, replaced the RJ45 jack with one of these, given them to another friend who did not realize we were running a web server out of his house, off of his network card. And it had nothing to do with his operating system. Didn't have to hack his machine at all. And I passed all of his traffic through to him, so he had no idea what was going on. It was like the ultimate keylogger, except it was a packet logger that sat outside of his system, so it didn't trigger anything. If you want to take a look at this later on too, I'll have this hardware on me if you want to see it. That is phenomenal, people, and they're working on a Wi-Fi version of this. So you're going to have your Wi-Fi servers in your pocket walking around. Imagine the mesh networking we can do. This is the Lantronix export, and in order to buy one-offs from them, you have to do a little bit of social engineering. They don't want to sell these to us yet, but we can get them. Case in point, here you go. You can get one-offs if you're clever about it. Lantronix, Lantronix. A one-off will cost you about $50. That's a phenomenal price point if you consider what this is doing in that size of a package. Okay, I'm running behind, so we've got to get going. Set ultimate goals. I'm a hardware person, so I think everyone at some point should see assembly. It really hurt my heart that recently on Slashdot there was a whole article, a discussion about should we even bother with assembly anymore? I wanted to smack somebody. It made me so mad. Ultimately, your end goal should be like assembly and FPGAs. How many of you were familiar with what an FPGA was prior to coming to con? Okay, a lot of you. In this community, great. So, microcontrollers. Since we want to extend our code into the real world, you have several options. Pick. Those are microchip stuff. You can program those in C. You can program them in assembly for free with the microchip tools. The C compilers will cost you money. You can also program them in BASIC. Atmel AVRs, same story. Motorola, like 68HC11 if you're old school. My favorite is actually the SX, even though they run hot. Yes, I know they run hot. You do embedded systems design. I still like them because you can overclock them and have fun. But I'm going to show you something that I probably shouldn't. I'm going to anyway. There is a company that is developing an embedded systems chip that a lot of people might not be aware of, and that's Microsoft. It's called the .NET CPU. I got to test this chip. It's since been taken from me, but I photo documented all of it because I wanted to prove that I had it. Has anyone heard of the Spot Watch from Microsoft? That's the chip that was in the Spot Watch. And when the Spot tanked, they decided to try and go for the educational market with this .NET CPU, which if you look at it is strikingly similar to a basic stamp module in terms of size and shape for that DIP package format. I'm running out of time, so all I can say is I hate the thing. Stay away from it. Unless you're a C# programmer, and then God help you, you shouldn't be doing embedded system stuff anyway. So, code reaches into reality. Everyone flashes LEDs. I was going to do that. I'm going to skip that because we're running out of time. Because flashing LEDs is the hardware equivalent of Hello World. If you're getting into hardware, it's just a good way to check your line to see if your signals are high or not. Everybody knows that. So I thought it would be more fun to teach you how to make some stuff move. So I'm going to talk a little bit about some basic components. Again, I chose a basic stamp to demonstrate this stuff today so that code isn't the issue. And if you're new to hardware, I would suggest finding some chip you can program in so you can concentrate on dealing with the hardware. So you're not dealing with multiple things at the same time. Don't worry about, if you want to evolve and start doing C code later on, that's fine, assembly. But don't have more than one hurdle in front of you at a time if you're starting in hardware as a neophyte. Trust me. So DC motors, we all had them as a kid. We took a battery, we took the little DC motor we had in our slot car or whatever, and we touched the wires to the battery, and the motor spins. And then how did the other way when we were a kid? We switched the wires around because we knew that if we changed the polarity, it would spin the other way. Just like when you put your slot cars on the track and you wanted to make them crash. You put one facing this way and one facing this way because you reverse the polarity. So how do RC cars deal with this? Because there's obviously not a 6-year-old with a battery sitting there switching the wires. They use a switch, which is the simplest piece of equipment to understand and also the basis for all of our computer systems. Digital logic, 0 and 1, binary. So the simplest part to make, period. If you don't believe me, I'm going to do a really fast demonstration of making a switch, and you can all do this at home. This is really elite here. This is wire. These are wire cutters. This is a wire stripper, by the way, if you've never seen one like this. Strip the end of that guy. You ready for this? This is the really elite part. I'm about to make a switch. Are you ready? Switch is open. Switch is closed. Wow, that's phenomenal, right? Really? No, seriously, hardware is seriously that easy. So you ask yourself, well, how can I make a motor go backwards with just a switch? Well, you use 4 of them. And you create what's called an H bridge. And the reason it's called an H is because it resembles the shape of an H. And really quickly, and again, I'm going to skip it. I was actually going to have you participate in the very first human H bridge project, where I was going to actually hand wires to 4 different people and have them be the switches. But I'm running low on time. Basically, if I close switch 1 and 4, I'm sending electricity that direction through the motor. If I close switch 2 and 3, I'm sending the same electricity this direction through the motor. Voila, with 4 switches, I have the ability to take a DC motor, go forwards and backwards. We have our first part of our RC car, the drivetrain. By the way, anybody care to guess what happens when I switch close switches 1 and 3 together? It goes like this. And then the magic smoke comes out of your parts. And for those of you who are not familiar with the magic smoke, electronic components contain it. It's the stuff that makes them function. When you release it, they function no longer. Okay? A lot of people have the generic concept of the H-bridge down, but a lot of people also don't realize that you can use braking on a traditional H-bridge by closing switches 1 and 2. Anybody care to guess why that is? Because your DC motor acts like a generator, and it fights against itself. You can do the same thing with switches 3 and 4. If you're turning a coil through a magnet, you're going to produce a current. That's called a braking condition in our DC motors. So now we have forward, reverse, and brake. So we're well with my last little bit here. So how do I build an H-bridge that my microcontroller can deal with? I use transistors, because what is a transistor but an electrical switch that I can control with current? There are thousands and thousands upon thousands of websites online. Build an H-bridge yourself. If you want the coolest one I've ever seen, Mark Tilden's group has one where they use 6 transistors and they glue them together and bend the pins, and it's the coolest H-bridge hack I've ever seen. Look it up if you are familiar with Mark Tilden. He's the guy who designed the RoboSapien, and he's a phenomenal person too. There are also many manufactured H-bridges on the market. You can buy them, sample them, et cetera, et cetera. So we've got part 1 of our RC car done. What about steering? Well, we take our motor and we give it. For those of you who aren't familiar with POTS, it's short for potentiometer. It's a variable resistor. A servo is a DC motor with a gearing system and a potentiometer attached to the shaft so that I can get positional feedback. Who here is not familiar with servos in any shape, form whatsoever and know nothing about them? You take that one, and I need one other person. Can you run up here really quickly to the front and sit in this chair for a second? You guys are going to help me with something. Okay, so for those, I'm sure many of you are familiar with hobby servos. Basically, it's just a geared DC motor. How does it determine the position? Are y'all familiar with, how many of you know what tau is, RC time constant? Okay, I got like 1 or 2. This is your tidbit of knowledge to take back so you can be more elite with your hardware friends like me. If I have a resistor, capacitor, and I put electricity through that resistor to that capacitor, it will have a charge cycle that will go up like this and a discharge that will come down like this. The amount of time it takes to charge and discharge is a constant. We refer to it as tau, which is right there, R cross C, or R times C. So if I have a pot, which is a variable resistor R, and I have a known constant capacitance value, and I can measure tau, I can determine what the value of that resistor is. It's a simple equation. I told you hardware is easy. What a servo does is it has components inside to determine what the R is based on tau. That's it. Really simple. So the pot provides the position. So how do I control it? How do I actually send a position to it? How many of you are familiar with servo control with PWM? Only a few of you. Okay, PWM stands for pulse width modulation, which is how you actually control a servo and tell it to turn to. Now, you guys that have the servos in your hands, if you turn it, you'll see that there's a mechanical stop, right? You only get about 180 degrees of travel out of it. That's because the standard servos were actually made for hobby airplane guys way back in the day to do the flaps on their wings and things like that. We're going to actually do a servo hack in a second to show you how to make these continuous rotation so we can use them as wheels on our bot if we want to. So, pulse width modulation. Long story short, it's duty cycle. The amount of time your signal is high versus your signal. The width of the pulse determines the position this guy is going to look for. Standard servos use a 20 millisecond refresh rate. Who triggered it? I must have bumped a wire. I have something for you. I don't know what was, maybe you guys were all how many people were slamming it with data? Just you guys? Hang with me here for a second. I'm going to show the rest of you the page. This is the page that they were all looking at. If you look, toggling the laser on, I guess it's already on. Laser off, I just shut it off. That's all running directly from this hardware here. So those of you who want to control stuff at your house remotely from the web, things like that, this is the type of module you'd use. They went to the Hack Here page, and it was Shmoo1862. Told you it wasn't going to be hard. Which brought them to this page. When they toggled this light, they actually controlled the blue light over here. And it was on a 5-second cycle. So that was the in-talk hack challenge. I think it's the first one. Has anyone ever done a hack challenge in their talk before that you know of? Yes. Now I'm going to show you how hard it is to write code to control a servo. Okay? And even if you're not a programmer, you're going to get totally lost in the details here because it's really elite. Yeah, now they're going to start toggling my lights. Are you ready for that? See how elite this is? That's it. That's the basic code right there to control servo to center position. Wow. It's 1, 2, 3, 4 lines of code in BASIC. Yeah, it's way beyond most of you. So I'm sick of hearing people at these cons say, I don't deal with hardware because it's too hard. Look at this. Okay, you guys are right. Did you see the talk before me? Did you see the code that they were discussing and filtering packets and how complicated and the last talk last night before out and dealing with statistical analysis? No, this is simple, guys. More of you need to start building stuff, okay? You need to enter hardware contests. So anyway, really quickly, because I've got like 5 minutes left, I want these guys to do a hardware hack with me. So not only will I have the first actual in-talk hack, I want to do the hack challenge. I'm going to do the first in-talk hardware hack as well. You guys need a pair of wire cutters. And let's see, we're racing against the clock. See if I can alter a servo for continuous rotation in less than 5 minutes. And people who've never touched a servo before to do the same thing. Take the screwdrivers, okay, and then I've got one right here. You guys are going to follow along with me. Go ahead and sit in your chair if you want. Standard servo. Anyone got a stopwatch? Anybody? All right, here we go. This is the front, this is the back. 4 screws on the back. Take a screwdriver, take the screws out. And I gave you guys my good screwdriver, so I might be able to do it as fast. So while they're doing that, I'll continue to talk. Pulse width modulation, by the way, is built in as an instruction in most micros these days. So the development of code to control servos is simple. Here's a little trick for you. You can also use pulse width modulation to control an H bridge. So not only will you have forward, back, and braking, but with pulse width modulation, you can actually control the speed. Because you can set the duty cycle, which is the amount of time that it's signal and low to that H bridge, and if that cycle is at 50%, you get half of the speed. You get all 4 screws out? Okay, you guys are faster than me because I'm talking. On the front is a part called the horn. You see the screw in the center of the horn. This is the horn. There's a screw in the center holding that on. Unscrew that. So not only can you use pulse width modulation to control a servo, to control a DC motor through an H bridge, or even just a DC motor straight for speed control, you can also use it LEDs to do dimming effects, those fade in, fade out effects. So you just hit 3 things with the same piece of code. You got the horn off? What you're going to do is you're going to pull the bottom plate off. You see how you're going to separate this? I've got them separated. And okay, so this is the base part like you see up there, and my gears actually stayed in here. pieces apart like this? Yes? Okay, and you got your horn off? Okay, with the horn off, you're going to pull the gear out that the horn was attached to, and only that gear. And it's okay if you don't, because there's only 3 of them. They're easy to put in. And somebody's do-do-do-do. Okay. There it is. And again, I apologize. I had a webcam set up so you could all see this. It's not functioning. Take your wire cutter. There's a little notch on the front. Yeah, you just push it out. You got to pull your horn off. Just pull straight out. You're going to clip that mechanical stop off. Okay, done. Then you're going to take your base part. The part that is inside the bearings is the potentiometer that we talked about. You're going to take your wire cutters, and you're going to cut that that plastic tab. Done. You're going to put that gear back on that bearing. You're going to put the top, the tab that's on the main gear. I screw the screws back in. I put the horn back on. Done. Servo modified for continuous rotation. What was that? Less than 5 minutes? 3? Okay, what does that give me? It gives me the ability to take my servos instead of a DC motor and use that for drive in an RC car type device or for whatever device that you're building. Okay? Again, with the mechanical stop removed and the pot cut, the pot's no longer going to provide feedback. So now when I send the same pulses that I said to go to position left or position right, it's going to keep spinning and it's never going to reach that position. I've just created a wheel for drive. Same thing for the other direction. And the proportionate amount of pulse change that I send to the left or the right will determine the speed. So I have a controlled geared DC motor at this point for less than, these are about $6. That's phenomenal if you consider the amount of manufacturing that. Okay? That also allows me to do something called skid steering. If I had individual control over both wheels, skid steering, I can go left and right with the different speeds instead of dealing with the servo in the front. So now you have like 6 options to build your RC car at home, right? Now, so we got DC motors, H-bridge, servo, PWM control, add your favorite wireless link. I don't care what it is, Bluetooth, RF, whatever. Go buy an off-the-shelf controller, HackAveX kit. All you need is something that can talk to your micro, and you're done. You've just built an RC car. But, and by the way, there was the solution, Shmoo1862. Okay. But if you're going to have a microcontroller there anyway, screw this making RC car stuff. We're hackers. You just built a robot. Wow. I went from teaching you how to build an RC car in a 50-minute presentation to building a basic chassis for a robot in less than 50 minutes. Come on, that's pretty phenomenal, guys. It really is. So if I've got the micro on there, I throw on a couple sensors, I have autonomy. Ta-da! Just like the Shmoo guys at DEF CON, I think it was 12, had the bot that drove around looking for vulnerabilities in the access points. I think it was DEF CON 12. Did you guys have that bot out there? So, basic structures in place. Any questions? Blue light special? Yes, Render got the blue light special. Or you got the blue light special. I don't want to take this home. It's actually a really nice laptop bag. Anybody wear a size medium shirt, by the way? I really like this shirt. You all get the joke, right? 2 megahertz. Sorry. And I've got a bunch of other crap. Do I have 5 minutes for questions? Yes, no? Is it lunch? Okay. Questions, comments? Basic intro to stuff. Again, like I said, not a how-to as much, except I did show you how to do a servo hack. By the way, you can purchase servos that have been pre-modified if you're really too lame to take out 4 screws, cut 1 tab, and take off 1 potentiometer. They do sell them pre-modified. These are standard Futaba servos, and those are yours to keep, guys. I just want the tools back. Any questions? Yes? There's a lot of, it depends on what you're designing. There are a lot of bot chassis out there that will accept a standard servo footprint and have standard servo headers on them already. Personally, if you want speed, DC motor obviously. With a DC motor though, if you want really tight control over it, you're going to have to pay or design a much more complex H-bridge or basically just a motor controller at that point. which there are tons and tons on the market. If you're going that route, you're going to match your motor controller to your motor anyway. So there are benefits to both. I build some robots with servos. I build some with DC motors. Depends on what I'm doing. So yes.
Have you looked at the Arduino processor?
I have. I'm not very familiar with it, but I try and sample everything. How many of you are familiar with Parallax's new processor, the Propeller? Okay, the Propeller was designed on FPGAs, which is why I asked the question I did enter about his FPGAs. FPGAs in the wild, in professional circles, are used to prototype chips before they actually spend the money to make the IC, which is why I said, hey, you've got these cool utilities that you're running on your FPGAs. If you make the ICs, which has a really high initial cost, but when they do that, then they can sell the ICs for a lot less money than the $2,000 FPGA. And then how many of you would say, I want to buy that $200 IC so I can drop it in and have my cracker type device? That's the reason for doing those. Like the Propeller was designed on an FPGA, beta tested, if you will. It's a way to beta test hardware without paying the cost, because with an FPGA you can reprogram it over and over and over again. How many of you have studied Verilog, VHDL, or AHDL by chance? Those are hardware description languages, just like HTML is a descriptive language describing how the web page is going to look. The hardware-based languages describe physically how you want the fuses burned inside the chip. Any other questions, comments? I didn't get shmoo-balled, I'm glad. Anyone else? I'm going to throw one other thing out there. Oh, yes.
Just a quick question. I'll encounter hardware sometimes, and I'll see that it ends in something like .mot or M16C, and it's a reflashing. Have you ever experimented
With reversing the firmware?
the firmware flashing?
With reversing firmware, or? There are a bunch. One of the possibilities is you now have a really expensive paperweight. For real. Depends on the type of chip it is. If you can extract the firmware off of something and mess with it in like a simulator, it's usually better to do it that way. I have messed with that a little bit. That's a good question. I mean, that's a good point. The whole point of this hardware talk is hardware is easy. Once you get your hardware in place, then all your changes are done in your firmware, and that's an easy thing to do for you guys, right? Yeah? Yeah? No? I saw another question. No? I'm going to ask, if I seemed a little frazzled today, I'm going to just throw this out there. My home was robbed last night. I got the phone call right before, last night before coming here. All of my servers have been stolen physically, so physical security, the whole gun talk. So if you, the reason I point that out is if you try and go to my website right now, because I was going to put this up for you and I was going to give you links, my servers are physically gone. My wife called me last night. So if I was seeming a little, that's why. Thank you for bearing with me. I had a great time doing this. I'm sorry that the webcam didn't work so that I couldn't show you the stuff more. I will have all this stuff with me. If you want to come see it, play with it. If you want advice on how to procure free equipment and things to test and play with, just let me know. Drop me a line. I'm very approachable. And you should all enter my contest at DEF CON this year. So, lostboy.net. Anything at lostboy.net will get to me. I have a catch-all on the emails. Except the server's not there right now. So, any other questions? No? Thank you. Anybody want a servo? I don't want to hit anyone in the head. All right, but if I hit somebody, it's your fault. Oh, thanks a lot.